Hi, I'm Guam Pilsan, and today we will be taking a look at competition number 12515, sprint number 28. The question says, Bill has a 3x3 square of chocolate that is divided into 9 unit squares, as shown below. He randomly chooses an internal grid line of the bar, breaks the bar perfectly along that grid line, and randomly chooses one of the 2 resulting pieces to keep, throwing away the other one. He repeatedly does this until exactly 1 unit square of chocolate remains. What is the probability that his final square was the bottom left unit square of the original grid? Express your answer as a common fraction. So, there are 4 lines that he can cut from. 1, 2, 3, and 4. And we want to find the probability that the final piece will be this piece over here. So, it's hard to think of it from a 3x3 square. So what we're going to do is we're going to first look at it from a smaller scale. So if it was just a 1x1 square, the probability would be 1. And if it was a 1x2 square, the probability would be 1/2. What if it was a 3x1 square? Then he can cut along this line, and then if he cuts along this line, there's a 1/2 chance that he'll get it right. But also he can cut along this line, and if he cuts along this line, there's a 1/2 chance, and he chooses this side, then it'll just be the same thing as this. So this will be 1/2 plus 1/2 times 1/2, and we have to average these out. This evaluated will give us 3/8. And for a 2x2 square, you can cut along this line or this line, so the probability will just be 1/4. And for a 2x3 square, if he cuts along this line, it is just the same thing as the 2x1 square if he chooses this side. So it's just 1/2 times 1/2 plus, or if he cuts along this line, it is just this is just the same thing as the 2x2 square that we just did. So plus 1/2 times 1/4 plus, or if he cuts along this line first, then and he chooses the bottom one, there is a 1/2 chance that he chooses the bottom one, and then it'll be the 1x3 square. And then we have to take the average of this, and then once we calculate this, it'll give us 3/16. Now, for the 3x3 square. If he cuts along line 1, and then he chooses the left half, there is first of all, a 1/2 chance that he chooses the left half, and then what is left is a 1x3 square. So that's 1/2 times 3/8. That's if he cuts along 1. But he can also cut along 3. So it's the same thing. And what if he cuts along 2? And if he cuts along 2, first of all, he has to choose this side. And there's a 1/2 chance that he chooses that side. And if he does choose this side, there's a 3/16 chance that he ends up with the correct square. And then the same thing can happen if he cuts along 4 over here. And then you have to take the average of this. And then once we solve this, we get 9/64, which is our final answer. Thank you for listening.
Hi, everybody. This is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.